Assalamu alaikum. I am Jahangir Alam, lecturer in physics at Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class, and still I am carrying on my regular activities. Dear students, I also hope all of you are well by the mercy of Almighty and carrying on your regular studies, staying at home. Right? Dear student, in our previous class we have discussed about the very basic items about wave, right? We have discussed about the definition of wave, different types of wave, properties of wave, and some important terms relating wave, right, dear student? So today we are going to discuss one kind of wave, that is progressive wave. In our today's class we will see the equation of progressive wave and some mathematical problem related to progressive wave, right, dear student? Our today's class is very important for you, and I hope you will be benefited from this class. So dear student, let's start our class. Now we can see the definition of progressive wave, dear student. In the definition it is stated that when a wave propagating from one layer to another layer of a white medium progresses continuously in the forward direction, then it is called progressive wave. Okay, dear student, it's a very important definition for your upcoming exam, right? So dear student, now we can see a short video for better realization about progressive wave. Dear students, now we are going to the expression for the progressive wave. Okay, dear student, in the figure, this figure indicates a progressive wave. The wave is propagating from A to C, right? So this figure can be illustrate many situations of progressive wave. So at first we can consider this figure indicates the displacement of a particle executing simple harmonic progressive wave with respect to time. Dear student, if we consider this is x-axis which represents time and this is y-axis which represents the displacement of the particle executing simple harmonic progressive wave, right? Dear student, you know, in progressive wave the particle of the medium does not change its mean position, just its change is or it displaced from the mean position in either direction, but the net displacement of the particle is 0, right? So here the particle is vibrating in the y-axis or in the along the y-axis when the time is represented by the in the x-axis, right? Dear student, suppose when the time is 0, then the displacement of the particle is also 0. Then suppose for a specific time t, so suppose this is time t, then the displacement of the particle increases to maximum value, and the maximum value of the displacement is called amplitude of the wave, right? So this is the amplitude of the wave. Then if the time is 2t, then the displacement of the particle become again 0, that is the particle is moving from this position to maximum position, then with respect to time it come back to the mean position, which is represented by this figure. Again if the time is 3t, then the displacement of the particle will take place in the opposite direction, that is the particle will back to the or move in the opposite direction like this. And when the time is 4t, then it will back to the mean position, then it will back from the lower point to mean position. So in the meantime the particle will execute one complete oscillation, right? So dear student, so if we consider this complete oscillation, this is positive half cycle and this is negative half cycle. The positive half cycle is denoted by this half cycle and the negative half cycle is denoted by the negative portion, right? So dear student, since we are going to consider the displacement of the particle executing simple harmonic motion, if we consider suppose the displacement of the particle in this position, that is when the particle is displaced like this from the mean position, this is the displacement of the particle at a particular time. This displacement is denoted in this figure like this. This is the mean position and the particle is displaced mean position to this position, right? If the position is denoted by P, and in the meantime if the particle makes an angle theta at the center of the circle, that is student, if this angle is theta, you know this is a right angle triangle, this is a right angle triangle because this is right angle. That is student, if the displacement of the particle is denoted by y, and you know the maximum displacement of the particle is called amplitude. So this is the maximum displacement of the particle A. This is the radius of the circle. That is shown. This is also the radius of the circle. This is also A. So in this triangle, this side is denoted by y and this side is denoted by A. So this is a right angle triangle. So this side indicates the hypotenuse of the right angle triangle and whose value is A, and this indicates the perpendicular of the triangle because this is the angle of the triangle, and you know the opposite side of the angle is perpendicular. So y indicates the perpendicular, A indicates the hypotenuse and y indicates the perpendicular, and you know sin theta is equal to perpendicular by hypotenuse. Here perpendicular is y and hypotenuse is A, right? So dear student, from this expression you can write that y is equal to A sin theta. So what does y indicates? Y indicates the displacement. Y indicates the displacement of the particle. So displacement of a particle is denoted by this expression, right? So dear student, we can write the displacement of a particle executing simple harmonic motion if denoted by y. So y is equal to, we can write A sin theta. You know A is amplitude of the wave and theta is angle or phase angle. Again, you know from the definition of angular velocity is denoted by omega. You know from the definition of angular velocity, omega is equal to theta by t. There is from the expression we can write theta is equal to omega t, right? So we can use the value of theta in this expression. So the expression will be y is equal to A sin omega t, right? So this is also an equation for the displacement of a particle executing simple harmonic motion, right? So dear student, here the expression y is equal to A sin omega t indicates the displacement of the particle placed at a point. But we have to know the displacement of all particle of the medium, right? Suppose if we would like to get or see the displacement of a particle, like this is a point denoted by P. If we would like to get the displacement of the particle from its equilibrium position, and if the particle is placed or situated at a distance of x from the mean position, restaurant, you know the displacement of a particle depends on its phase angle. You know here theta is angle or phase angle. So first we know we need to know the phase angle of the particle, and here you have to keep in mind that if the wave displaced from A point to B point, then the displacement, then the distance is known as lambda. There is, you know, this length of the wave is called lambda, that is the distance traveled by a wave during one complete oscillation is called wavelength, right? So for one complete oscillation, for one complete oscillation the particle or the wave execute 360-degree angle or twice pi angle, and in the meantime it will travel a distance of lambda. So here we can write that, so for the distance of lambda, the phase difference is twice pi, right? So for the unit distance, the phase difference is twice pi by lambda, right? So for the x distance, we are going to get the phase difference for the particle which is situated at x distance. So for x distance, the phase difference is twice pi by lambda into x. This is the phase angle of the particle P. Okay, dear student, so the phase of the particle P is twice pi by lambda into x less than the phase of the particle at point P. So this is the expression for the displacement of the particle which is situated at point P. So if we would like to get the displacement of the particle at point P, then the phase of the particle will be subtracted from the phase of the first particle. Therefore the expression will be y is equal to a sin omega t minus twice pi by lambda into x. So this is the displacement of the particle denoted by p. Again, dear student, omega, that is angular velocity, can be expressed as 2 pi f. Omega is equal to 2 pi f. So if we replace omega by 2 pi f, then the expression will become a sin 2 pi f t minus twice pi by lambda into x, right? Again, dear student, v is equal to f lambda, right? Therefore f is equal to v by lambda. So if we replace f by v by lambda, then the expression will become y is equal to a sin 2 pi v by lambda into t minus twice pi by lambda into x. So dear student, in the both term of the phase, twice pi by lambda are common. So if we take common twice pi by lambda, then the expression will become y is equal to a sin twice pi by lambda into vt minus x. Dear student, this is the expression for the displacement of a particle executing simple harmonic progressive wave. Okay, I hope you got it. This is very basic and important expression for the progressive wave. So we need to use this expression to solve some mathematical problem. Okay. Now I would like to mention here that if the wave propagate in the opposite direction, right, then the displacement of the wave will be y is equal to a sin twice pi by lambda vt plus x. In the main expression it was vt minus x, and this expression will become, if the wave propagate in the opposite direction, then it will be vt plus x, right, dear student? I hope you got it. So dear student, now we are going to see some mathematical problem related to this expression. Okay, dear students, here is our first mathematical problem. It's a very important and interesting math, so I hope you will enjoy it. The equation of a progressive wave is y is equal to 5 sin 200 pi t minus 1.57 x, right? This is the expression or equation of a progressive wave, right? Y indicates the displacement of the particle executing simple harmonic progressive wave. So here they said that find out the amplitude, right? We need to determine the amplitude, frequency, time period, wavelength, angular velocity, and finally velocity of the wave. So we need to determine many quantities from the expression. So to solve this type of problem, dear student, first we need to write the given equation or expression in the question. So in solution, first we will write the given equation. Given equation which is given y is equal to 5 sine 200 pi t minus 1.57x. This is equation number 1. Dear student, you know the standard expression for the progressive wave standard equation for the progressive wave, you know, y is equal to a sine 2 pi f t minus twice pi by lambda into x. This is equation number 2. So dear student, this is the standard expression that we have already discussed in our today's class, and this is the given equation in the question. Now we need to compare these two equations to find out these required quantities. Dear student, you know in the standard expression here a is called amplitude of the wave, but in the given equation you don't know what is the amplitude of the wave. So if we compare this equation with the given equation, then we will find the required quantities. Dear student, the previous quantity, that is the quantity placed before the sine function, is a, which is known as amplitude. In the given equation 5 is placed before the sine, so here 5 is equivalent to a, here 5 is equivalent to a, so the amplitude of the equation is 5 meter, right? So now we can write, comparing 1 and 2, we get a is equal to 5, that is amplitude. A means amplitude, so amplitude of the wave is 5 meter, that is amplitude. Amplitude is 5 meter, right? Now they wanted to know the frequency. There is shown in the standard equation, you know, f is the frequency, f is the frequency of the wave, and f includes the first term before the minus sign in the standard equation. So if we compare this part of the equation with this part, right? So first part of the phase is need to be compared with the first part of the given equation, then you will find the value of f. Again again 2 pi f t is equal to 200 pi t. That is when we have comparing this part with this part. So from this expression we need to determine the value of f. Therefore if we would like to get the value of f, so we need to determine 200 pi t divided by 2 pi t. So after the calculation you will get the value of f will be 100 hertz, right? So we have already determined the value of frequency, right? Now we need to determine the time period. That is when you know time period and frequency are inverse related, that is time period is inverse quantity of frequency. So time period t is equal to 1 by f. Okay, you know the value of f is 100 hertz, so 1 divided by 100 and you will get 0.01 second. This is the time period of the wave. Now we need to determine the wavelength. That is when in the standard equation, you know, lambda indicates the wavelength. So the second part of the phase includes wavelength. So we need to compare this part with this part. Then you will get the value of wavelength, right? Now 2 pi by lambda into x equal to 1.57x, right? So from the expression we can write lambda is equal to 2 pi x divided by 1.57x. So after the calculation you will get 4 meter. So this is the wavelength of the wave. Then they require the angular velocity. That's when you know angular velocity is omega, and you know omega is equal to angular velocity, omega is equal to 2 pi f, right? So if you use the value of 2 into pi into f, the value of f is 100 hertz, right? So it will be 200 pi, and the unit will be radian per second. So this is the angular velocity. Finally we need to determine the velocity of the wave, right? Velocity v is equal to f lambda. That is when you know v is equal to f lambda. Here value of f is equal to 100 hertz multiplied by lambda is equal to 4 meter. So after the calculation you will get 400 meter per second, right? That is when I hope you got it. Okay, so you need to practice this type of problem from your textbook. It's a very important math. Dear students, here is our second mathematical problem. It is almost similar to the first one. So they said that the equation of a progressive wave is y is equal to 0.9 sine phi into x by 15 plus 2t divided by 0.3. So we need to determine the amplitude, frequency, time period and wave velocity of the wave. So similarly, first we need to write the given equation and we need to write the standard equation of a progressive wave. Then we need to compare these two equations to find out the required quantities. Okay, so dear students, first we are going to write the given equation. Here the given equation is y is equal to 0.9 sine pi to x divided by 15 plus 2t divided by 0.3. That is when for the better realization we can rearrange this equation like or y is equal to 0.9 sine 2t 0.3 into pi plus pi divided by 15 into x. This is equation number 1. Just we multiply pi with the both term of the phase and we exchange the first quantity with the second quantity, because in the standard equation you will get t in the first term and x in the second term, right? And standard equation y is equal to a sine 2 pi f t. In the standard equation there are t in the first expression, so we exchange the second expression with the first expression plus twice pi by lambda into x. This is equation number 2. Okay, now we are going to compare these two equations. Comparing equation 1 and 2, you will get, that's when First we need to determine the amplitude. In the standard equation, you know, A is the amplitude of the wave. So A, the previous term of sine function, here the previous term of the sine function is 0.9. So we can say the amplitude A is equal to 0.9 meter. Okay. Then they said the frequency, you know, frequency F indicates the frequency which remain first term of the phase. So we need to compare this term with the first term of the given equation. Again 2 pi f t equal to, we can write 2 t pi divided by 0.3, or f is equal to 2 pi t divided by 0.3 divided by 2 pi t. So after the calculation you will get 0.1 by 0.3, right, and it will give 3.33 hertz. So this is the frequency of the wave. Then they said the time period, you know, time period t is equal to 1 by f. So if you use the value 1 by 3.33, so it will give 0.3 second, right? And finally they said the wave velocity of the wave. V is equal to f lambda, right? Oh, dear student, first here we need to determine the lambda. First we need to determine the lambda to calculate the wave velocity. Okay. So to calculate the lambda, we need to compare this part with this part. This is second part of the standard equation with the second part of the given equation, right? Here 2 pi by lambda into x equal to pi by 15 into x, or lambda is equal to 2 pi x divided by pi x into 15, right? So if we cancel out pi x, so value of lambda will be 30 meter. Okay. Now we need to determine the wave velocity. You know, wave velocity v is equal to f lambda, right? So using the value of f and lambda, you know, you got the f, the value of f is 3.33 and the value of lambda is 30 meter. So after the calculation you will get v is equal to almost 100 meter per second, right? This is the final answer for the progressive wave. So dear student, I hope this class will help you a lot for your upcoming exam, and actually this is an important class for you, right? So dear student, you need to practice this type of problem at your home from textbooks, but if you have any confusion you can ask your subject teacher, you can ask me, right? So dear student, many good wishes for all of you. Thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.